Okay, we're setting up. So we proved the intermediate value theorem in the previous video. Now we're going to take a look at how homework instructions for proving using the intermediate value theorem, proving that a function can be solvable. Let function f be continuous on the interval a to b. Assume that instead of k, we're going to use m this time. M is a number between f of a and f of b. So f of a is less than m and m is less than f of b. Then there exists at least one number c, or x value, on the interval ab, which satisfies f of c equals to m is solvable. So here we have our interval a to b. And here's our function f. So we have f of a and f of b. So if f of a, if we can prove that f of a is less than m and f of b is greater than m, then and that this is continuous, then we can say that the f of c equals to m is solvable. So the first thing that we do is assume that f is continuous. Assume f is continuous. On our interval a to b, and that m equals 0, then the conditions for f of a is less than 0 and f of b is greater than 0 would lead to the conclusion that f of x equals to 0 is solvable for x, is solvable for x, where f of x equals 0. Now it doesn't necessarily have to be 0. It could be 0, like if we're looking for a root. But what we're saying here is assume, first of all, f has to be continuous. And we're saying that m is some number. In this case, 0, whether it's 0. In this case, it's easier to show that when m is 0, then f of a is less than 0 and f of b is greater than 0. In other words, when f of a is less than m and f of b is greater than m, that would lead to the conclusion that f of x equal to whatever m is, in this case 0, is solvable at c. So when f of a is less than m, so from here we're going to have our steps. Okay, steps to prove. Okay, first thing we want to do is define a function. Define it. Define a function. Y equals to f of x. And that's what we did here. We defined it. Okay, and that's what we did here. We defined it. So you have to define the function first, and then 2, define a number. Define a number m. Okay, or our y value. And then step 3, establish that f is continuous. Establish that our function f is continuous. Without it being continuous, we can't prove that it's solvable. It has to be continuous. We have to be able to have continuity in all points, because if we don't, then the whole thing breaks down. Choose an interval AB, and this may be given. Establish 5. Establish that m is between FA and FB. In other words, FA is less than M, which is less than FB, or it could be FA is larger than M and M is larger than FB if it's going downward. Here's A, and here's B, and here's M. So this would be, now f of A would be larger than M. This is FA here, and FB. So now f of A is larger than M. So I could go either way. And then step 6, invoke the conclusion. Invoke the conclusion of the intermediate value theorem. Okay, so that's what we're going to do in our next videos explaining the homework. So this concludes this video.